In trying to figure out what the derivative tells me, I mean, we already know that, for example, it equals to, if you find the derivative of a function, so let's say you have a function f of x, and you find its derivative, that derivative is going to tell you the slope of the tangent line at a point, at any point. Okay, we also know that it gives us the instantaneous, not the average, but the instantaneous rate of change. Okay, so, as a consequence of this, remember we went over this already, but let's say, you have a function here. Let's say this is f of x. And so any point where the function is going to be increasing, notice, so like for example this whole area right here, the tangent line is going to have a positive slope. So if, for example, the derivative is positive, that tells you the function's increasing. If the derivative is negative, like it is right here, that'll tell you that your function is decreasing. Okay, and then we also talked about the second derivative, how if it's concave, if your function is concave up, then the second derivative is positive, and if your function is concave down, that means the second derivative is negative. But now these are, abstract concepts. How does this relate to different situations? So let's try to interpret all of this in some real life situations. Let's say we have a function, c of, let's say c of a. And c of a represents the cost of building a house of a square feet. So I'm not going to give a specific function. All this means is that you've got this function and you plug in a number here in for the square footage, and this function will tell you how much it'll cost to build that house. So for example, let's say I want to interpret the following. Okay, so we have these two situations. Now notice this is c of 1,000 and this is c prime of 1,000. So what this tells me is that when, if I want to build a house of 1,000 square feet, a 1,000 square foot house, what this tells me is that it's going to cost $300,000. $300,000 to build. Okay, so that was a pretty easy one, But now what does this tell us? What does that mean that the derivative at 1,000 is equal to 350? So if you go back to our original two things that it tells you that the slope of the tangent line at 1,000 is 350. So then you go, what in the world? What does that tell me? Doesn't tell me anything. Well, let's try to think about our next definition, the instantaneous rate of change. Now, rate of change is general. And here, though, so the rate of change here is talking about the cost of building a house. So this would be the rate of change of the cost of building a house. So basically what this tells you is that the rate of change, how fast the cost of building a house is going up is $350 at that instant, exactly at the instant where you have built 1,000 square feet already. So another way of saying this that makes a lot more sense is that once you have built 1,000 square feet, since this is the rate at which it's increasing, the next square foot, to build one more square foot after 1,000, so right away the next square foot is going to cost $350. Now that doesn't mean that if you want to build 1,000 more square feet that it's going to cost $350 each one. It's just telling you that exactly at that instant where you've built 1,000 square feet, if you want to add one more square foot, it's going to cost you about $350 for that 1 square foot, because that's the rate at which the cost is increasing. So hopefully that makes sense. Okay, so let's do another example. Let's suppose we're investing $1,000 at an annual interest rate of R%, so this is variable, for a fixed time of 5 years. And B of R is the balance. So we plug in an interest rate percentage, and this is going to give us the balance that those $1,000 are worth after 5 years. Okay, so this first one says that if the R, this 6 represents R, so if the rate is 6%, the balance after 5 years is $1,350. Okay, now what does this guy tell me? Now this is in dollars, sorry. Okay, now this one tells me, so this is exactly the same thing, the rate, percent. So exactly when the interest rate is 6%, what this tells me is this is the rate of change of the balance. So what this tells me is that if my next, in this case, percentage rate, so for example, if you raise the interest rate, if the interest rate goes up, so in this case it would be 7%, then what that means is that my balance, this is how fast it's going, so my balance would increase by $81. So that's how much more I would have. So in other words, if you turn this into a rate, that means that right here, exactly at when the interest rate is 6%, the rate is $81 per percentage rate. So if you go up to 7%, it would be around $81 more in balance. Okay, so here we have an example of, we have all this information about our function, and we're trying to figure out a possible graph. Now you should know that there are several different correct answers, so we'll just do one and talk about a couple of the possibilities. So the first one, let's do this one. This one says f prime at 5 is equal to 3. So what this says is that when x is equal to 5, the derivative is equal to 3. So this means that it has to be increasing at exactly at 5. So exactly right here, it has to be increasing. Okay, so I'm just going to write that right there just so that I keep that in mind. Now, the next one says that f of 2 equals to -4. This guy right here is the y value. So what this is saying is that when x is equal to 2, y is equal to -4. So my graph has to pass by this point right here. So it has to cross there somewhere. Okay. And then f double prime at 5, so the same x value, 5, is equal to -2. What this means, remember, is that it has to be concave down. So that's what that tells me. So right here, it has to be concave down. So it has to look, something like that kind of a deal. And then the limit as the limit as x approaches infinity of f of x is equal to 0. So what that means is that no matter whether it's coming from up here or down here, it has to be going towards, so it has a horizontal asymptote at 0. So it has to be going down like that in one of these parts. And then it doesn't have any information about over here on negative infinity. So it just has to satisfy those. So let's try to draw a function that satisfies those. So we can do something that looks like this. Maybe something that looks like this. Sorry, didn't mean to do it so curvy. And then over here, it has to be increasing and concave down. So that's increasing concave down, and then it has to go towards 0. So that satisfies all of those requirements.